I call this a lot of the times a prototype tool that helps us understand how to get to a production point very quickly. So it delivers the customer high precision prototypes so that they really understand their design. But then we've already developed the tooling to understand what they need. We might even have software written for partial automation or full automation. It really allows us to pare down what we need for production. So this is very complex and very customized. It has to be very precisely aligned so that it's not causing any pointing errors in the assembly. Making sure that we have enough adhesive that the part does not fall off and it can hold through all the environments it needs to, but then also not too much that it's over the clear aperture of the optic, causing any issues with the beam degradation through its whole steering range. At Benchmark, we have a few optical engineers that work with us here. We can really help miniaturize a lot of systems because we're not using mechanical fixturing on the optic themselves and you're not doing manual alignments. On a system like this, the customer will come with just an idea of what they want and we can work with them to create that design. So if the customer comes in and needs very precise optical alignment, we can customize this tool to suit their needs. It's actually aligning some optical windows to motors that's allowing us to steer our laser. It's doing that through a hexapod for the fine alignments, and then it's using a robot for coarse alignments. And the robot is also used to do material handling, so it'll pick up the optic, get adhesive on the optic, and meter the amount of adhesive that's transferred. So it's using a vision system to actually monitor that, and then it uses the UV that's built into the gripper itself to cure the adhesive on there. Another assembly that gets built on here is the frame of the whole laser steering system. And that frame has an objective lens in it, or a lens that we're placing in it so that we can focus the beam down exactly where we need on our customer's solution. It then will lower it down into the frame, which is a very tight space, and that's why we're using that robot with a custom gripper there. The custom grippers we make are very small, so then we can actually fit it into very tight spaces. So we can shrink that overall assembly and then be able to still get the optic in where we need to do the alignment. The customer we were working with had an initial past generation design for this assembly. It was much larger, and then they weren't using automated alignments, so they have a manual alignment of their laser steering assembly to their entire system. We were able to actually shrink that total footprint and get rid of that manual alignment to the station by really holding our alignments very tight. We have to hold very, very tight alignment specs to eliminate and reduce the cost, but also to shrink it in size. So by doing that, I mean, the customer at this point is very happy with what we've been able to deliver.